Hi, my name is Chris Miller, and I'm a student at the University of Idaho. My goal in this video is to try to help you understand how to solve problems with chirality, specifically how to correctly assign a chiral center as S or right. And so to do this, I'm going to teach you first how to draw a kind of diagram I came up with. It looks something like a Newman projection. So to draw this diagram, just look at this molecule of methane here. Imagine looking at it from this perspective, as if the C was blocking the H, so that these three hydrogen atoms over here are all going to end up on the same plane. So I draw it looking like this. I draw this hydrogen, the one in the back, right here, and then I draw these other three hydrogens like this. And so I kind of just pretend like the carbon atom is invisible, and I have something that looks kind of like a Newman projection, but just for a chiral center. So the way this method works when you're solving a chirality problem in the real world is that you always put the group assigned 4 in the back. And so here's an example of a simple problem. Say you had to solve this chirality problem. Put bromine up here. So you would know that this one's going to become a hydrogen, and it's going to be in the front, and you'd assign numbers as normal. So it's 1, this is 2, 3, and 4. So put the 4 group in the back, in this case the hydrogen. So again, I would draw this, putting the hydrogen in the back, and then I would draw this skeleton like this. And it's easier to draw it this way because bromine, there's already 1 up and there's 2 on the bottom. So we know bromine's going up here, we can assign this as 1. Now the trick is, since you have to turn this molecule around, since bromine is in the back currently, you need it in the front here, is these 2 numbers are going to switch. So you can always know 32 becomes 23, or however that works out. So, like this. And at this point, you can easily assign chirality just using the normal rule. So, since it's going counterclockwise, it's sinister or left. So, I'm going to go ahead and erase this and show another simple problem, solving in the same way. So, say the molecule you've got looks something like this. And let's just put a chlorine down here, again, keeping the problem simple. So, once again, go ahead and draw in the 4 here, where it would be the hydrogen atom, and then assign the chirality numbers as you usually would. 1, 2, 3, and 4. So drawing the same kind of Newman-like diagram, we need to keep that 4 in the back, so we put the hydrogen right back there. And then this time I'm going to draw it this way. And the reason I'm doing it this way instead of the other is that it's simply easier. Oops, kind of in the wrong spot there. And get that better there. Is it's basically, since you already have 2 parts going up anyway, it's easier just to think of it that way. So the chlorine's going to go on the bottom, once again getting assigned 1, and then 2 and 3. Now again, because this is in the back, these numbers are going to switch. So you're going to have to say 2 and 3 here. So doing the normal rule, this is going clockwise, and so it's going to be R. Now, the place where this method also especially helps is when you're doing Fisher projections. Fisher projections are extremely easy to do when you're drawing them this way. So take a Fisher projection problem like this. Let's see, OH group here, O, and then H, OH, and then CH. Just say it look like that. So, say you needed to assign the chirality of this place here. So, you would just know that Fisher projections basically mean this. The OH group here, and these are in the front. H is here, and it's in front. These carbon atoms here in the back. So now, assign these numbers as normally. So this is 1. In this case, this one has all those oxygens up there. So this will be 2, 3, and 4. Now, drawing this kind of Newman fragment here is extremely easy. Putting 4 in the back, as usual. So here goes the H. And then draw the 1 group up here, because that's easiest. And assigning numbers here is easy, because you just look at it. It can even help you tilt the paper sometimes. But basically, if you looked at it from this perspective, you would know this is going to be left, and this is going to be right. And so you draw it up here just like this, left and right. And then you can assign the projection here, making it clockwise, and that's R. And so if these 2 groups have been switched, you would simply look at it from the other perspective. and this would become left, and this would become right. You get the idea, but it makes doing Newman projections, Fisher projections extremely easy. So I hope that helped you and that it gave you a good handle on how to solve chirality problems.